All right, so the first blank, stoichiometry. Is the study of the relative quantities so that's the blank, relative quantities of reactants and products in a chemical reaction. Now, the word relative in this context, it means like comparing, okay? So relative to each other, so it's like comparing, and we're comparing quantities. So, this is the whole main key of stoichiometry. If you understand this, you will understand the unit. So it's very, 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 very important that you get this for the whole rest of the next month of chemistry. You can use the number of moles for a given reactant or product to find the moles for any other reactant or product. Okay, so it's like if we think here, reactant goes to product. And it could be like multiple, okay? So S for plural, not for solid. Okay, so the whole thing is that if I find the moles of a reactant, I can compare it to see how many moles I should have of products, okay? So we do, and we compare. And we should get the moles of the products. Okay? So you find the moles of one thing, you do a comparison to find the moles of the next thing, and then you can see it. And it goes the other way too. You can find the moles of the products, do the comparison, apply it to moles of reactants or another product. Okay, so how do you think we do a comparison? If we're making, say, I don't know, magnesium oxide from magnesium and oxygen, and I start with 2 grams of magnesium, okay? I put that into moles. I calculate it into moles. How would I know kind of how much magnesium oxide I make? What do I have that gives me a comparison? This is definitely like a green type question. What do we have in a chemical formula that helps us give reference to comparing different reactants or products?
Coefficient in front of the
Chemical or whatever it is, compound or element. Yes. Your coefficients, right? Your coefficients are like your molar ratios. From Science 10, that's what we said. We said those coefficients, those numbers in front, okay, of a chemical equation is a mole ratio. So when we do a comparison, we're going to do our wanted over given kind of thing, where we use our coefficients. Okay? So if you can kind of comprehend that, oh goodness sakes, what's going on? Okay, that was special. All right, so consider the following chemical reaction. So we have 2 ethane gas plus oxygen makes CO2 and H2O. What is this? Well, what kind of reaction is that? Combustion. Very good. Because I have a hydrocarbon plus oxygen making my combustion products. Write the ratio for all components of the reaction. So, if I was just to look at a ratio, I would say there's 2 ethane molecules for every 7 oxygen molecules to every 4 carbon dioxide and 6 water vapor. So for every 2 ethane molecules that are burned, I need 7 oxygen, I'm going to get 4 carbon dioxide, and I'm going to get 6 water vapor, right? Okay, very good. So what amount in moles of CO2 is formed if 2.5 moles of methane reacts? So what we do is you say and always write your information right underneath of what you're talking about. So since it's ethane gas, write the moles, like that's what you know is 2.5 moles right under ethane gas. Okay? And I'm trying to find my moles of carbon dioxide. So this is like my given. So you can put a G over top of this one. And this is your wanted. So put a W over top of that one. So now, since what we can do is we're going to do our mole comparison. So that's wanted over given. Okay? So we go 2.5 times by 4 over 2. Wanted over given. So would result with 5 moles of carbon dioxide gas. So this is my given, this is my wanted. So my fraction is always wanted over given for the coefficients. Okay? So similar to what we've already done before with our mole comparisons. But that, you guys are doing stoichiometry without realizing it before. Look how smart you are. Okay? Okay, so got that? We're good? Okay. So how about this one? What amount in moles of O2 is required to react with 10.2 moles of ethane gas? And we still are assuming we're doing a combustion reaction here. So you're still using the same formula, but I would write it, I guess you have it there written out for you again. So, you know that you have 10.2 moles of ethane gas. So write that down underneath of the ethane. And that's your given. Okay, that's what you've been given information about. And you want to find how many moles of oxygen are required. So we times this. So you take your moles times by wanted over given. So this is our given. Convert this to a thing. So we go times by 7 over 2. And the moles you should result with is 35.7 moles. Next one. What amount in moles of H2O gas is formed when 100 millimoles, so that's not a spelling mistake, it's milli. So I know, the first time you guys saw that, it tripped some of you. So it's millimoles. So if you don't remember, okay, your conversions, you can go here to page 3 of your data booklet, and you see the symbol M there. So that means milli, so it's 10 to the power of negative 3. So that 100 millimoles is a smaller number of moles. If you wanted to just keep it in millimoles and give your answer in millimoles, that would be fine too. Like, you don't have to put it in moles to compare it. You just need to know that your answer is millimoles. So what we know or are given is about our CO2, 100 millimoles. Or if you converted it, it would be 0.1 moles, right? Okay, thanks. And what we want to find is the moles of our water. So times by wanted over given, and we get 150 millimoles or 0.15 moles. Okay, rock on. Okay, I'm gonna convert this to a different type of file so that I can you hit the stop button on the thing there, Reed? The red.